Okay, so we are looking at section 1.6, midpoint and distance in the coordinate plane. Your goals for this lesson are to develop and apply the formula for midpoint, use the distance formula and the Pythagorean theorem to find the distance between 2 points. All right, and so those are our goals. So let's remember what the midpoint formula says, and you can't see a thing I'm doing because I've got this thing frozen. So again, section 1.6, midpoint and distance in the coordinate plane. Those are the goals we just talked about. So here's our midpoint formula. If we wanted to find the midpoint between this point, which is the order pair x1, y1, and this point, which is the order pair x2, comma, y2, we basically need to find the average of those x coordinates to be our new x coordinate, and the average of the y's to be our new y coordinate. So this formula right here gives you that midpoint. You add the two x's, you're adding the two x's and dividing by 2, and you're adding the two y coordinates and dividing by 2. So let's test this out with this example. We are trying to find the coordinates of the midpoint of segment CD, where C has endpoints at -2, 1. So -2, -2, -1, which would be right here. That's point C. And D has endpoints at 1, 2, 3, 4, 2. So here's point D. All right. And so we want to find the midpoint of this segment. And there's my segment right there. All right, so can you help me out with this? Nate, no, not here. Mitch.
So let's go so your x1 and your x2 are going to be
All right, so I'm writing down the formula again, and so what am I going to plug in?
your x1 is going to be -2, x2 is going to be 4.
All right, so you got -2 plus 4 divided by 2, and then -1 plus 2 divided by 2. Are we okay with this?
Yeah.
All right, and so at this point we're simplifying, and to help us simplify here, we're going to end up getting what is our midpoint, Audrey?
1 and
Because this is 2 over 2, so you're saying that's going to be 1.
yeah,
And what's the 1/2? Are we okay with 1, 1/2? And 1, 1/2 would be this guy right. No, it's not. 1, 1/2 would be this guy right here. Does that make sense? Okay, so that's our midpoint. Now I can call it point M.
This is possible.
Yes.
What happens if we did 2 over 2? Do we have to simplify it?
If you did 2 over 2, you want to simplify it to 1. All right, let's take a look at the next example. This one says find the coordinates of the midpoint of segment EF with endpoints -2, 3, and F is 5, -3. So this time maybe without a graph, can you tell me what you're going to plug in? A little help here. Alex. You want me to write -3 plus 5?
Yeah.
Yes?
Or is it the other one?
We want the x's. So what are the x coordinates here?
Oh, 5 minus 6.
5 is an x. And what else is x? I'll call this is x2, y2, for example. This is x1, y1, for example. So what are my x's that I'm adding?
5 and -2.
5 and -2. Okay, so I'm going to say I want to add -2 plus 5 Divide that by 2, and help me out, Alex, what about the y?
3 minus
So 3, let's say 3 plus a negative 3, so we always get into the habit of adding these two coordinates together. And when we simplify that, that turns out to be what, Carlina?
Do you want it as decimals? Well, I'd have 3 over 2, 0.
3 over 2 comma 0, do people agree with that?
Yeah.
I mean, if you wanted to write it as 1.5 comma 0.
Yeah, I wasn't sure if you wanted.
That's
Do we
fine
have to
also.
write it as, well, yeah.
As long as your answer is exact, I'm okay with that.
Okay.
If it turned out that it was, you know, something was like 2/3 comma -1, I would not like you to say 0.6 comma -1, because this is not equal to 2/3. It's not exact,
So how
right?
do we,
Because this would be maybe 0.6 repeating, that might be okay, but I'd rather you use the fraction that
how do you graph the fraction?
graph it?
Yeah,
What do you mean, you mean plot it
yeah.
on a coordinate plane?
Mhm.
Yeah, I mean, if you're gonna graph this one, are you talking about 1.5?
Yeah, but I'm just confused on how you do 3, 2, 0, how to graph it.
We're just gonna go over 1.5.
Oh,
How would you grab 2/3?
well, yeah, I know, but.
I just go over 2/3 of the way between 0 and 1. Yeah, okay, let's move on. What about this type of problem? This is a little different. This says M is the midpoint of segment AB. A has coordinates 2, 2, and M has coordinates 4, -3. Find the coordinates of point B. So let's graph what we know. We know that A is at 2, 2, so this is point A, and we know M is at 4, -3. 3, so this is M, but M is the midpoint of some segment, AB. We don't know where B is. So where should B be here?
No.
No. Is B gonna be up here? Is it gonna be down here?
Probably.
Yeah, right, because it's some kind of a segment that extends something like this. Does that make sense? So we are looking for the coordinates of this point B. We don't know what they are right now. We're trying to find them. Okay? I think the easiest way to do this kind of problem, let's say A is 2, 2, M is 4, -3. I think the easiest way to do this problem is to say, what's happening to get from A to the midpoint? How is the X changing? If you read my writing, it just looks so neat right now. That's supposed to be a 2. So how did the X change? It went from 2 to 4. So what did we do?
Add 2.
Add 2. So we want to do the same thing. So what should the X coordinate be? 6. So this is going to be 6, something. And then what happened with the Y coordinate? The Y coordinate went from 2 to -3. So what happened there? -5. And so we need to do that again.
-8.
-8. So I think that 6, -8 should be our ordered pair for the other endpoint. So this is the type of problem where you're given one endpoint and you're given the midpoint and you need to find the other endpoint. So there'll be some like this on the homework and some like this where you're just given 2 endpoints and you're trying to find the midpoint. Okay.
Or you just find the rise over the left.
The rise over the run, explain, what do you mean?
Like, couldn't you find the slope between A and F, and then you just find it between?
Okay, so you're saying if I find the slope, I've got to go down 1, 2, 3, down 5,
Yeah.
and to the right 2?
Yeah.
And you're saying just do that again?
Yes.
So we go down 5 and to the right 2,
Yeah.
and that should get you to the same point?
Yeah.
I like that. You can think of it that way, or just what's happening to the coordinates. I like the slope idea. You're kind of tying it into slope. I think that's great.
I don't get them, I just want to.
Okay, all right. So let's talk about distance formula now. In a coordinate plane, the distance d between 2 points, x1, y1, and x2, y2, is given by this formula. Have you seen the distance formula before?
I've seen it before.
Have you used the distance formula before?
No.
Okay, this is so exciting, man. Such an exciting day. So the distance formula is here, and basically what's happening? You are taking the two x coordinates, you are subtracting one of them from the other, and then you are squaring that difference. And then you're taking the difference in the y's, and you're squaring that difference, and you're adding them together, and you're taking the square root of the whole thing.
No, it's not that bad, it's not that bad.
Oh, you just do that in your
Not-
calculator.
Yeah, can you just do?
You can do this on your calculator for sure. Or you can do it by hand. So this is our distance formula. So let's take a look at this example. It says find the length of AB. Oh, I'm not reading this right. This should say find the length of segment AB, right? And the length of segment CD. Remember, if it doesn't have a bar over the top, we read it the length of, right? And then determine if segment AB is congruent to segment CD. So let's start off by finding the length of segment AB. And before we do that, I'm just going to remind everybody what the distance formula is. You take the difference in the x's, square it. Take the difference in the y's, square it, and add those two together and take the square root of the whole thing. So in this case, if I want AB, A is the ordered pair, oh boy, thank you, 0, 3, and B is the ordered pair 5, 1. Everybody agree?
Yes.
So can you plug these things in for me into this formula, Olivia?
So it'd be 5 minus 0 squared root.
So like you're thinking if this is x1, y1, and this guy is x2, y2?
Yeah,
Okay, so you said what? 5 minus 0?
yeah.
5 minus 0
Squared
squared,
plus 1 minus 8
1 minus 3
squared.
squared. Everybody okay with this?
Yeah.
And so if we simplify this, we get square root of 5 squared plus, is it negative 2 squared? 5 minus 5, 1 minus 3 is a negative 2, but notice I put the negative 2 in parentheses. If I don't include the parentheses, and I try and do this on my calculator, I'm going to get the wrong answer. So make sure you have the parentheses. And so in this case, it turns out to be square root of, is it 25 plus 4?
Yeah.
Yeah.
And are you getting square root of 29?
Yeah.
Okay, remember, the square root of 29 is your exact answer.
Oh, we don't have this there.
Hold up, that's your exact answer, and you could be done if we want the exact answer. But if you want a decimal approximation, that would be what? 5 point, oopsie, I don't want square root anymore. My bad.
5.3. So 5.39.
5.39?
Rounded.
Is that rounded to 2 decimal places? Do people agree?
If you round to 2 decimal places.
That's what I'm asking.
Oh, I get it.
All right, are we okay with this?
No, I have a question. I'm sorry, I had to.
It's okay.
Like, you have 20, like, say you have, like, 16.
The square root of 16?
Yeah, not, we got 16.
Square root of 16?
Could you
is
do
just
4?
and that would be an exact answer. Right, are we okay with this? All right, let's find the length of segment CD. We're not done yet, we're trying to find CD. All right, and that means we need the ordered pair for C, and we need the ordered pair for D. And can you help me out with those ordered pairs, Rachel?
Negative 1, 1 for C.
C is, what is it?
Negative 1, 1.
Negative 1, 1 for C.
And D is negative 3, negative 4.
Negative 3, negative 4?
Yeah.
Do people agree with Rachel? Is that okay? All right, so again, we call this guy x1, y1, and this guy x2, y2. Can you help me out with the square root of, and what are we going to write here? Nathan Slattery.
Okay, negative 3, or in parentheses, negative 3 minus negative 1, which should be negative, yeah, squared.
So negative 3 minus a negative 1, whole thing in parentheses, squared,
Plus,
plus,
parentheses, -4 minus 1 parentheses squared.
Do people agree with Nathan?
Yes.
Okay, and so if we're simplifying this, we end up getting square root of, you're saying this is plus minus a negative plus a positive here? So this is going to be a -2 squared, does that look right?
Yes.
Plus what?
-5.
-5 squared. And so it looks to me like we're getting +4 plus a +25. Is that square root of 29?
Yeah.
Same answer. So that means that the length of AB, the length of segment AB is equal to the length of segment CD, which means that segment AB is equivalent to segment CD. Are we okay with this?
Yes.
That was a lot. Don't be one.
I do want to highlight something because I see this mistake often with students, and that is people get mixed up between the distance formula and the midpoint formula. Which formula am I doing subtraction, and which formula am I doing addition? Connor,
Are you giving us a final on the quiz?
I thought you were going to answer my question.
Oh, how do we know?
Well, I'm asking which formula involves addition and which one involves subtraction. Connor?
Okay, well, distance, and we subtract this in parentheses and square, then add.
Oh, okay, good, all right, you're right, there's addition in there also. But yeah, I meant between the coordinates, right?
Subtraction for distance. and-
Subtraction in between y1 and y2 and x1, x, and then yes, there is addition
Yeah.
between.
So
But the midpoint formula,
Is
by
there
the way,
adding the coordinates?
we're adding, right? Adding at the midpoint, adding, right? So don't be that kid that subtracts in their midpoint formula.
do we have to put a
Don't be that kid. Do you have to put the comma in?
Yeah.
Must do, because it is an ordered pair that you're giving. So left parentheses, a number,
Are
comma.
you gonna give us the formula on the quiz?
Oh, what an excellent question. And my answer to you is,
So she's gonna give us the formula.
No.
taking a sneak peek. Formulas are not provided. So you need to memorize midpoint formula and distance formula. Pez, for Connor for asking about whether formulas need to be memorized, and the answer is yes. Let's move on. We're looking now at, where are we at? We did this. Okay, thank you. Right triangles. First of all, a right triangle is going to be a triangle where one of the angles is a right angle, meaning it measures what? 9 degrees. So one of the angles we already know, it's 90 degrees. All right, in a right triangle, there is some terminology associated with a right triangle. The two sides that are adjacent to the right angle, think of it as a side and another side that actually form that right angle, those sides are called the legs of the right triangle. The hypotenuse is the side across from the right angle. So here's the hypotenuse, and it is the one that's across from the right angle.
Things like the hypotenuse.
Okay. All right, so let's take a look at, are we okay with this?
No.
What's of the two?
Are you gonna put this recording on Blackboard for us?
I am.
Oh, please.
Okay, let's say that this is a right triangle, okay? And so I'm going to ask what segment is the hypotenuse of this triangle, Devin?
GI.
Segment GI, do people agree? All right, so this is the hypotenuse, and that means that segment GH is a leg, and segment HI is a leg. Everybody okay with this?
Yeah.
It's just the opposite side of the right angle.
So wherever the right angle is,
Right angle.
across from that's going to be the hypotenuse.
Oh, okay.
Okay?
Ready?
All right.
Wait, you actually might be right.
Yeah, I was thinking that was right.
All right, moving on.
Hypotenuse is always the longest part of the.
The hypotenuse is always the longest side. hypotenuse is always the longest side in a right triangle. Okay. Moving on. So this leads us to a very famous theorem about right triangles called the Pythagorean theorem. In a right triangle, the sum of the squares of the lengths of the legs is equal to the square of the length of the hypotenuse.
Last year.
No.
Did you learn this? How many of you have heard of the Pythagorean theorem?
Oh, yeah.
Most people have. Okay, 8th grade. So,
So we did hypotenuse.
so focus please. If I call this side A and this side B, these two sides are called the legs, and I'll call the hypotenuse C. And what this theorem is saying is that if you take the sum of the squares of the legs, that means take leg A and square it, take leg B and square it, and take the sum of the squares of those legs. So A squared plus B squared, and that's going to equal the square of the hypotenuse. So that's where we're getting A squared plus B squared equaling C squared. Are we okay with this?
You actually plug in numbers in here.
You could actually plug in numbers and see, the nice thing about the Pythagorean theorem is given any two sides of a right triangle, you can find the third side. You can find the missing side. You can't do that with just any triangle. It only works for right triangles, right? Because we have this theorem. We have no special theorem about any other triangles. Olivia.
You have to memorize these formulas for the test?
Yes, you need to know all these formulas for the quiz next
Wait.
Thursday in 6 days.
Are we gonna have to do like, I use the Pythagorean theorem to solve this?
As long as you're writing the Pythagorean theorem, I will recognize it as the Pythagorean
Okay.
theorem. Okay, Elizabeth?
So, will A squared plus B squared always give you C squared, or will it ever be a time where it won't?
If A and B are the legs of a right triangle and C is the hypotenuse of that right triangle, this will always work. Okay? All right, moving on.
Wait, so how exactly do you find, like, the measure of A? Like, when it's on a graph like this?
Yeah, so let's take a look at this example. Can we look at this one?
Yeah.
Okay, it says use the distance formula and the Pythagorean theorem to find the distance from A to B. Round your answers to the nearest tenth. So in this case, we're supposed to do this in two different ways. So let's try distance formula over here. Distance formula. Actually, you know what? Take it all back. I'm not going to be able to work like that. Let's do distance formula, and then down here we'll do Pythagorean theorem. All right, so if I want to find the distance from A to B using the distance formula, remember that is us saying D equals x2 minus x1 squared plus y2 minus y1 squared. Agreed?
Yes.
All right, can you help me out? A is negative 2 comma 3, B is 2 comma negative 2. So what are you going to plug into the distance formula here, Elizabeth?
You do 2, go to parentheses, and then 2 minus negative 2.
2 minus a negative 2, quantity squared.
And then you do plus, in parentheses, negative 2 minus 3.
Quantity squared. Now, I do want to point something out, because Elizabeth started with this one, and she said 2 minus a negative 2. But then she went this, oh, no, she did, you kept it consistent, didn't you? And then you did negative 2 minus 3. You're all good. And really, but my point was, even if she had, even if she had gotten this other one in the other way, like what? What do I mean? 3 minus a negative like this, it still would have been the same answer overall, because we're doing what with this subtraction? We're squaring it. You with me? So this is going to turn out to be 5 squared, but the way you had told me before, it was going to be negative 5 quantity squared. It's still going to be 25. Does that make sense?
Yeah.
Yeah.
But do you want to try and be consistent?
You should try and be consistent, because even though it doesn't matter in this formula, don't forget the other formula where we're subtracting. What formula is this?
Oh, no.
Slope intercept form.
Slope formula, it makes a big difference. You gotta be consistent in this formula. Does that make sense?
Yes.
All right, so let me be consistent, just, even though it doesn't matter in this one, it does matter in slope, so let's try and be consistent. And so you told me this was gonna be what?
-2 minus 3 x squared.
Are we okay with this? Yes, so this turns out to be, is this plus a positive? Is that 4 squared?
Yeah.
And this is gonna be a -5 squared? So does that give us 16 plus 25? Square root of 41.
6.4.
Approximately 6.4. I'm gonna leave it as square root of 41 for right now. Are we okay with this?
Yes.
Do you want us to write approximately or like approx?
I mean, I would write length of AB equals square root of 41.
But it says round to the nearest tenth.
Oh, my bad. I should read the directions, shouldn't I? If all else fails, read it. So AB is approximately equal, little double squiggle, what is it? 6 to the nearest tenth? 6.4. Are we okay with this?
Yeah.
Pardon me?
Squared 41.
And your calculator, just do square root of 41.
Okay.
Okay, now, that's great, but that was all using the distance formula method. You with me?
Yeah.
That was all the distance formula. Now, if we're going to use the Pythagorean theorem method, that means we need to find, whoa, hold up. AB, if we're trying to find the length of AB, that is which side of this right triangle, Connor? What do we call it? Is it a leg or the hypotenuse?
Leg.
So AB is the leg?
Yeah.
Do people agree?
I agree.
I don't know.
What is
Isn't AB the one that's across from the right angle?
No.
Yeah.
C is.
Here's AB right here.
Oh, we're looking at the.
Oh,
wrong
Here.
thing.
I thought you meant the blue.
Yeah, so
Yeah,
did I.
I thought you meant the blue.
Oh,
The little.
No,
I'm
we're asked,
looking at the small one.
we're
Yeah, me
asked,
too.
we're asked to find the distance from A to B.
Okay, never mind. Yes, it is the
Yeah.
Okay, let's look at like
Letters.
Yeah.
Okay.
We should have picked different letters.
So that means, I hear you. So in other words, we're trying to find the length of segment AB, but in our picture, they're calling that side C. Agreed?
Yeah.
Okay,
Oh.
so that means in order to find side C, since it is a right triangle, we can use the formula A squared plus B squared equals C squared. True? Okay, so now can we find the length of A? If they haven't written A on our picture, how long is that segment? A, count your way. Count your way from point C to point 4 units. 4 units. So I get 4 squared. Agreed?
Yeah.
And
Yeah.
then what is the length of side B, which is really the segment that goes from point A to point C? 5. You count your way. 5 squared. And so that is supposed to be equal to C squared, true?
Yeah.
So I can just do 16 plus 25 is equal to C squared. Right?
So
And that means
41.
41 is equal to the hypotenuse squared. So to solve for C, I need to do what to both sides?
Divide by.
C is being squared right now. So the inverse operation of squaring
Divide by-
something
divide by itself.
Square root.
is to take the square root. So we need to take the square root of both sides. Now, just so you know, when you take the square root of both sides of an equation, you technically need to remember that there's 2 solutions, a plus and a minus. So for example, if I say x squared is equal to 100, what number or numbers could I square to get me 100?
Negative 50 and 50. Negative 50. I mean, negative 10.
10 would work, right? Isn't 10 squared equal to 100?
Yeah, or negative 10.
Or negative 10.
Oh,
So if I take the square, hang on, if I take the square root of both sides, that means my solution for my little equation here, x would equal 10 or x would equal negative 10.
Oh, gotcha.
All right, so over here, c could technically equal positive square root of 41 or negative square root of 41. But does it make sense to talk about a negative side length of a triangle? Is that really going to have a negative square root of 40? No. So for our purposes, we're just going to not worry about that, and we're going to say that c is just equal to square root of 41.
Which you have to round to nearest 10, so it's 6.4.
All right, so rounding, so we still get c is approximately equal to, what is it?
6.4.
My bad,
I,
6.4.
on the quiz, do you tell us we have to solve A to B using the Pythagorean theory?
It may say, solve it this way. It may say, solve it the other way. Or it may just say, find the length. And then you can choose which method you want to use. Okay.
Will they let us twice if we don't do the squiggly lines?
Yeah, because it means something different. That's for you.
Oh, she said no, so.
And,
Wouldn't equal and then approximately.
you know, I'm trying to teach you to be precise mathematicians here.
So,
So
yes.
I would say use the double squiggle. That shows me that you know that it's not the exact answer, it's an
How
approximate.
about like a 0.5 extra credit?
Let me think about that one. All right, moving on. Okay. So the four bases on a baseball
I
field,
don't play baseball.
focus, the four bases on a baseball field form a square with 90-foot sides. When a player throws the ball from home plate to second base, what is the distance of the throw? So the catcher's trying to get somebody out who's stealing, and they're throwing right to the second person on second base. And so we need to find the distance of that throw.
Can we try this on our own?
Please do.
But I like trying things on my own.
I Put your name on the board. Okay, so we are back, and we are trying to solve this
I'm not.
distance problem. Tell me, what did you come up with, Isabella?
I got 0.
I think I know.
Phone a friend.
Liv. Okay, I got it 127.30.
How'd you get that?
I did the distance.
127.3. What did you
Wait, is
do?
that wrong? I
I
did
don't
the
know.
distance formula.
So tell me what should I write?
I have
So,
13
I wrote-
questions.
In parentheses, I did 90 minus 0 squared.
So you're using the distance formula, and you're finding the distance between 0, 0 and 90, comma 90? I'm just rewriting them because it's kind of hard to see it on this. Okay, and so what should I be writing?
So, parentheses, 90 minus 0 squared,
Okay,
and then plus parentheses, 90 minus 0 squared again.
okay,
And then that could be like 90 squared plus 90, or 90 to the second power, whatever.
90 squared plus 90 squared.
Which has to be 8,100 plus 8,100.
Okay, so that's 16,200.
Yeah, and then you take that to, like, what do you call it?
And you took the square root of that,
Yeah,
and that's equal to what?
100 plus 7.3.
Doesn't it?
127.3. Do people agree with this?
Yeah.
All right, so that means that the distance is approximately 127.3. Are we talking about feet?
Yeah.
Oh, wait, you have to start the video.
I did. Thank you, though. Appreciate that. Otherwise, I'd be going back to start it up again. When
Rachel.
Rachel comes back. Okay.
Can you like round it?
Are we okay with this?
Yeah.
Did anybody use Pythagorean theorem instead? You did? Maya, tell me what you did.
So I did 90 squared
You did 90 squared.
plus 90 squared.
So like this length here, you're saying is 90, and this length here is 90, and this is a right angle, and you're trying to find this hypotenuse here. So you said 90 squared plus 90 squared equals whatever we call it, the hypotenuse squared, like that? Okay, so again, we're going to get 8,100 plus 8,100 equals that hypotenuse squared, and that gives us that 16,200, And if we take the square root, we will end up getting 127.3. Are we okay with this?
Yeah.
Either way is okay. All right, so that's it for this lesson. Thanks for watching.